recording in a few seconds. So welcome to our first webinar of the academic year. Today we're featuring Dr. Jonan Donaldson. My name is Alvin Fortuna. I am the junior graduate student representative and a doctoral student at Michigan State University. I'm joined with Ali Holmes, who is a doctoral candidate at Purdue University and is a co-senior graduate student representative. The purpose of this SIG, just to remind everyone, is to apply, advance, and extend complexity theories to inquiry, research, theory, and practice in a variety of educational contexts. Today, we welcome Dr. Jonan Donaldson. Dr. Donaldson is an assistant professor of learning design and learning sciences at the University of Alabama at Birmingham, where he built the recently launched Masters of Science in Learning Design and Learning Sciences program. His research centers on understanding and supporting learning as a complex system. He's a developer of learning experience network analysis, which is a design-based research method that uses network visualization to analyze qualitative data and generate data-driven design moves. He is currently developing a complex conceptual systems theory to understand socially situated conceptualizations of learning. His work also explores the nature of creativity, the dynamics of distributed conceptual change, and the development of AI-powered tools to make complex methodologies more accessible to researchers. If you'd like to learn more about Dr. Donaldson's work, we have provided a link in the chat to his personal website. So please help me welcome Dr. Donaldson.
Howdy. So should I go ahead and share my screen?
Yes, sir.
Okay. Okay, yes. I want to talk about embracing the mess. I'm Jonan Phillip Donaldson, UAB, University of Alabama at Birmingham. And I'll just talk a little bit about myself real quick. So I'm a learning scientist, in case y'all don't know what learning sciences is. It's an interdisciplinary field it has a start date, 1991. It has a lot of different, ideas from many different disciplines, but as a field, we tend to have a few ideas in common as learning scientists, and one of them being that learning is complex and messy, and has to be complex and messy, and I'll get into that in a little bit. I built the learning design and learning sciences programs here at UAB, master's and grad certificate. The master's degree started 3 weeks ago, and the grad certificate is going to start in the spring. So I've been busy and exhausted and really, really proud. One more thing about me before we get too far in, just so you're not disappointed. If you came here to hear an expert teach you things, it might be disappointing, because I am not an expert. I am a tinkerer, explorer, and I wanted to show you what I've been exploring and tinkering with, and then we can talk about how these things can move forward in the future with more tinkering and exploring. So basic assumption: everything about learning is complex, messy, and beautiful. And that's a learning sciences kind of basic proposition. And it's even, it's not just describing it, it's kind of definitional in learning sciences, that the definition of learning is a complex becoming and construction and all of those things. But the complexity goes even deeper in that another proposition related to this in learning sciences is it's complex and messy, and any attempt to clean it up and make it simple and clear and streamlined will destroy the possibility of learning ever happening. So you got to lean into the complexity and mess, which I do. So I'm not going to talk a whole lot about complexity science because y'all know what we're up to. Because yeah, you're my people. Y'all know about the many interdependent elements, self-organization, attractor states, sometimes a little bit of equilibrium or far from equilibrium, but we got a lot going on here. And of course, emergence and nonlinear dynamics, things like that. So I don't want to get into that because y'all know that stuff. Also, there are so many methods for studying complex systems. And I bet each one of you has a lot more expertise in some of these than I even could comprehend. So, of course, there's agent-based modeling and time series analysis, systems dynamic modeling of many flavors. There's probably 100 different ways of doing that. Nonlinear dynamic statistics, computational modeling, some qualitative. There's many kinds. But the last one on the list here, network analysis, that's my gem. I love me some network analysis, partly because I love pretty colors and visual things. So I want to talk a little bit about design-based research because it's the defining methodology of learning sciences. So it was invented in the early days of learning sciences. I said that we have a start date of 1991, and in 1992, the idea of design experiments was invented and published in the Journal of Learning Sciences. And that very quickly became formalized as a methodology called design-based research. And here's how it works. So you start with your contextual learning needs, and then you really understand that really well. And then you figure out what theories, learning theories and other theories, what theories would be useful in this context. And then you derive some principles from those theories, and then you use those to design some learning. Then you implement it, then you collect some data, analyze it, redesign it, implement it again, analyze it, redesign, implement again, analyze, redesign, and it keeps going. But I don't know if there's a consensus on this, but I think there's a kind of consensus that you can't call it design-based research unless you have at least 3 or 4 iterations. Yeah, so that's the main thing. So we have a little problem here, and it is so you implement your design, and then you collect data, analyze it, and then redesign the data. How do you do that? What kind of data do you collect? How do you analyze the data? And those sort of questions are still open. There's some pretty strong methods already, but a lot of them require a lot of expertise. And so it's really difficult for novice researchers to do design-based research. And in fact, in all of the learning sciences programs I know, they basically say to their PhD students, don't do your dissertation as design-based research. Wait until you become faculty, and then you can go do it. And I didn't want to do that, and so I want to make it easier, and so that's what I've been up to. So I've been developing this thing that I call a learning experience network analysis, or LENA for short, and it's an analytical approach for design-based research, and it is grounded in complex systems theory. Let me show you what I mean. But first, basic assumptions. Learning is emergent in complex systems perspective, context. I don't know how to describe it, but learning is emergent. Learning is complex and messy. Learning cannot be measured in reductionist ways. As in, if you're going to go do multiple choice exams, my assumption is that tells you absolutely nothing useful and causes more harm than good. little bit difficult person. Sorry, a little bit radical, but reductionist ways of measuring things, you can't really get at it. But learning can be measured and analyzed in expansive ways. I'm stealing the terminology from activity theory or cultural historical activity theory, this expansive perspective on stuff. So, learning experience network analysis, it's not something different than design-based research. It just serves to make one bit of the whole process a little easier for, especially for novice researchers. The analyze to redesign, this part right here, that's what I'm going for. So first, of course, you design a learning experience grounded in theory. And I'll just pop through a few theories I know, and just to embarrass some people in the room, maybe. So first, we got, the cognitive constructivist learning theory. And I guess we could trace that back to Piaget, could be before Piaget, but kind of got really formalized with Piaget. And then you got the social constructivist traditions that led to activity theory, starting with Vygotsky and then moving through a bunch of others. I put two people here, Engstrom, and but it's a little sad that I can't include everybody because there's so many of them, but it's useful to just think of these people, because if you go read these people, you get it. And constructionist learning theory, I use this one all the time. Love me some Papert. Learning by making, and the idea that construction of knowledge is most awesome if you're constructing a thing. It could be a tangible thing, or it could be a symbolic thing of some sort, but you're constructing a thing. As you construct the thing, you're constructing your knowledge that further informs the construction of a thing. A feedback loop starts forming, and therefore the most powerful way to set up learning to happen, which I do in every course I teach, is just have students make stuff. And that requires a lot of things that I don't have time to get into, but a lot of learner agency, a lot of productive failure and tinkering and stuff like that. Situated learning theory, I use this one a lot. Levenweger, ideas of community of practice, stuff like that. Transformative learning theory. Now, this isn't exactly the way that Mezirow framed it, but this is my framing of it, that transformative learning theory says learning is a transformation of your ways of knowing, your ways of being, and ways of doing, which, of course, he called frames or frames of reference and that sort of thing. For recognition theory, I couldn't put pictures of people here because there's no single name or set of names that lead the charge on this one. But the idea that cognition, instead of being symbolic representations in your brain, that cognition is inactive and extended and embodied and embedded. I use this one a lot too, and I get some critical pedagogy going. Usually in most of my designs, I got a little bit of this going. Frere, I wish I could pronounce his name better. And then a bit of other theories like self-determination theory, not exactly a learning theory, but it's really useful, especially if you want to say that we want to, for instance, increase intrinsic motivation. This gives us a framework to latch on to. And let's see if we can embarrass anybody in the room. Sorry, I love this one. The dynamic systems model of role identity. And this one is really useful. I'm not an expert in any way, but I use it for planning designs and sometimes for analyzing designs of learning. So then you've designed that thing, ground it in theory, and you go implement it. And then for this LENA process, you collect reflection papers. After they go through that learning experience, you ask them what worked and what did you struggle with about that process. Of course, you can ask them more questions too, but if you get them to really go deep on what worked and what were your struggles, that gets you some really rich data. Sometimes you have to scaffold their ability to do reflection, because often they'll just tell you what they did and you're like, okay, we got to learn how to do this and go deeper and actual deep reflection and focus on these questions. Really, what worked really well for you in this process and what were your struggles? And then you put your reflection papers, the struggles and the what worked, and maybe the meaning of experience or something. You can add more questions if you want to. You put it in qualitative data analysis software. I always use MaxQDA Analytics Pro just because it has stats function. It's kind of like mini SPSS built into the software itself. Makes the next steps easier. So you put it in here, and then you code those reflection papers for the struggles, what worked, and for alignment of those students, their experiences with the different principles from theory. So, for example, from, let's just take one of these, constructionist theory. The principles for that one are authentic audience, authentic purpose, and constructing things and doing design work and focusing on the process, not the product. Lots of generativity, lots of making, lots of creativity going on. Pride in your work, productive failure, relevance exploration, and tons of tinkering and exploration. So those are, like on the right, I blurred it out a little bit. Those are like different colors I've coded the theories and stuff like that. But you code for learning theories, then you code for the struggles, and then you code for what worked. And I actually use the same code book because I've worked on, I'd say 100 different projects so far. And I just keep building up my code book of the struggles and what worked. My code book is about 330 codes now. If you ever want my code book, I'll give it to you. And then you conduct your network analysis with cluster analysis. And here's how I do it. There's no correct way to do it, but this is just how I do it. So I start with correlation analysis, and that's why I use MaxQDA Analytics Pro, because it'll do the correlations, and then it'll export an Excel file. And in this sheet, for example, I deleted all of the values that are not significant at, I think this one was P is less than 0.01. I think that's what I was doing with this example. So you got this thing, and then you create a network map. I personally use UCINet. It's old, it's clunky, but it's the easiest network analysis tool, especially because I work with a lot of undergrads in my lab helping me make code data and make maps and stuff like that. And it's just so fast and easy for them to learn. Basically, zero learning curve. So you make your network map, and then you do some cluster analysis. Now, personally, I like the Gervin-Newman. There are other algorithms for cluster analysis that are newer and probably a lot better. But I use this one because it works and it's easy and fast. So each cluster there, oh, by the way, in each cluster, I want there to be some struggles, some things that worked, and hopefully some principles from theory. But each cluster for this kind of analysis needs to have at least one struggle in it and at least one thing that worked. Because I'll get back to that in a minute. I also run the between the centrality measures. And the reason I do that is then I could see which ideas. So in this map, all of the nodes are the same size. But then if I resize them according to between the centrality measures, that's a measure of how important a node is in. I explained it to my my students in my lab as it's the glue factor. How important is it in gluing other stuff together, not to itself, because glue doesn't. The function isn't supposed to be gluing itself to itself. It's the idea that it connects other things to other things, and how important is it in connecting other things to other things? The logic being that you can't address everything. So you'll start with the things that have the biggest centrality measures. And then you make a table here, a design moves table, where you say in each cluster, so each cluster is a row. So the first one would be maybe the red cluster, and the next one maybe the blue cluster, and so on. You'll have the struggles, you'll have what worked, you'll have the principles from theory, and then later, you'll make the design moves. Fill out the first 3 columns first, and then you make your design moves. The logic is that you need to leverage what worked and theory in each cluster to address the struggles in that cluster. So the design moves come from, you look at each struggle in a particular cluster, and you say, students who have experiences like this tend to be struggling with this, but what worked for them was like this and this and this. So how can we use what works to make those struggles better or go away? So that's the logic of it. So I'll show you some examples here real quick. Before I talk about the examples, so in higher education, I was at Texas A&M and now I'm at University of Alabama at Birmingham. I do it in a lot of courses in the university with professors. And we do we don't study the whole course. We take one part of their course. For example, leadership. In that course, we were looking at using the design thinking process to develop their leadership skills. So I've done all of those things: computer science, engineering, tourism, et cetera, et cetera, et cetera. In middle school, I did one study using this method. We were studying how students could learn science through sport. And then in elementary school, I did work with a colleague in Indonesia studying interventions for developing elementary school kids' AI literacy. So the first LENA examples, so I mentioned leadership. So in that one, we were using this design thinking for engaged learning model in an undergraduate level leadership course. And we don't need to spend any time on this model, but I did want to mention real quick that in the learning sciences, the idea of learning by making is really big, but also like collaboration is important, and situatedness and contextualized and meaningfulness and all of those things. So what better way than a design thinking project and engage the students in solving real world problems, designing the solution. So framing the problem, understanding the problem, human-centered, and then divergent thinking, convergent thinking, then project planning, prototyping, user testing, analyzing, design moves, multiple iterations, and then actually deploy the thing in the real world. So that's something that I did in this leadership course. So here's a network map. In one of the courses, we asked the students to write their reflection papers only about the design thinking project, not the rest of the course, just that part of the project. What did you struggle with? What worked really well? And I think they asked, we asked a few other questions like, what skills did you develop or something like that, leadership or something like that. But I think it was just one more question. Anyway, here's the network map, all clustered. This map was of only correlations at P is less than 0.001, so 99.9% like confidence. Of course, the Gervin-Newmans. When you do Gervin-Newman cluster analysis, it'll give you a Q value. That is the value of, it's called modularity. How well does the clustering actually represent what the data is telling us? And higher is better. So if it was below 3, the map is not good, and we need to get more data or something like that. Usually around 4 to 5 is very common. If you're above 6, that's very rare. So this is like kind of a very good, solid network map. So we've got these different clusters here. And so we translated that into the design moves thing, design moves table. So I'll just zoom in a little bit on one part. Let's look at the pink. So the problem the students were struggling with is they were struggling with the problem scope, keeping it realistic or something they can implement. They were also struggling with problem finding or identifying the problems. What worked really well for them was actually the instructions, and the professor did a little mini lectures. And some clarity of the process was really helpful for them. And also the theory, it's split into 2 colors because we made 2 design moves out of it. But from situated learning theory, engaging in the practices of a community of practice, in their reflections, they were all often indicating that idea. They didn't use those words, of course, but what they were saying really aligned with that. So we created a design move that says during the problem finding stage, which is stage 1, the groups will be asked to formulate the question as, how can we, our team, help blank, who the stakeholders are, address, and then there's their design problem that they're going to try to alleviate. Yeah, and human-centered, so the instructors clarifying also that they're not going to solve the problem and deliver the solution. They're going to be working with stakeholders on that. So that's just one example. I'll go back just real quickly. We color coded it. So like the red is all related to one design move. The pink is all related to another design move. The purple, another one, and the blue, another one, and so on for the next cluster, and so on and so forth. Yeah. So I want to real quick talk about limitations, what LENA can't do. So you can't use qualitative data, especially the what worked, you know, like the pre and post, like tests and things like that. That's not, that data is useless for this kind of analysis. And you can't really measure learning because there's no indication of like students learn more, students learn less. That's not in the map here. That's not in our analysis. So you can't really measure learning. And you can't do this microgenetic minute-by-minute real-time analysis of learning that learning scientists are obsessed with. And I like it, but it's really time intensive and it requires a lot of expertise to pull it off. But, video analysis, minute-by-minute video analysis is really hard work. But that kind of analysis doesn't really work for this. Just a bit of advice. I said tinkering. That's what I'm doing here. I'm not presenting my expertise here. I'm just saying, look what I did. I tinkered and I found something useful. You can too. And that's okay. I hope that your people around you give you permission to invent new methodologies. Before we move into the discussion, I just want to I want to mention a few things about this. The complexity. It's not just that you see the complexity, but this method, I think, I hope, it honors the complexity of the learning environment. So different students are different in their experience of any learning experience, right? The way they experience it is going to be different. By the way, that's not to say learning styles, because learning styles, it's a myth. It does not exist. Anyway, it's more about like different people are just, they experience things differently, right? But in this way, instead of trying to improve the learning activity by looking at just the lowest common denominator, okay, what's everybody struggling with? And then fixing that. This gets to the deeper complexity, and different kind of people maybe experience it different. That's not to say that each cluster is a different set of students, because some students' experiences will be in multiple clusters. But we have looked into that question, and students do tend to be aligned more with one cluster than another. For example, in another class taught by the same professor, there were two clusters that the best interpretation at the bird's eye view of the clusters was one of the clusters, the students were basically thinking of themselves as employees, and the teacher is the boss, and I do the work and turn it in and get paid in the form of grades. And they hated the class, and it was miserable and just torture. And then there was another group of students who were like, basically, it was kind of like, I want to be like my professor. I want to be that kind of expert. And this class is going to help me become closer to that expertise. And they loved the class, and they thought it was the most awesome class they had ever taken in their lives. So you see what I mean by different experiences. And one more thing that I think, just to reiterate, is often when we're trying to address problems in learning design, we try to figure out what is the struggle, and then we just try to fix it straight up. But this way, you're trying to look at what's connected to that struggle, especially what's working. And how can you leverage that relationship to make a change that's grounded in the data from the student's experience itself, rather than your expertise, which is why novice researchers can do this. They don't need any expertise. Well, they need some help with the learning theories, of course, the principles from learning theories, but not a lot. But besides that, they can do this easily. And they have. So wanted to say that. And then I want to give you some links. I'm just going to pop it into the chat first and explain what they are. So the LENA example number 1, that network map I was talking about just now in the last 10 minutes, it's presented in this journal article. And there's a link to it. And then another example, the next link is another project. It was also design thinking, but it was in tourism. It was in a tourism course. And then the third one was in a literature course. Oh, this one was so fun. This is, I helped a professor of literature. His expertise is science fiction and fantasy. I helped him redesign the core activity of the courses to be the students design role-playing games that are kind of like Dungeons and Dragons, but on other planets with other alien species. And so they have to design the worlds and the characters and the gameplay and all that as a literature course. Very cool. But that's explored here in this link. And then finally, the last link is this article actually presents the method with more detail. And if you go to that link, it has supplemental materials where there's a worked example with a lot of detail in it. And discussion. So in terms of discussion, I'm going to stop my screen share, but for the discussion, I would like it if it's not about I'm the expert and I'll give you the answer. I want to have a discussion about like what's next and what y'all can do, and that would make me happy.
I have a quick question for you. I know you mentioned that you can't use this tool to get learning, like, measure learning per se. So what would happen if you, like at different time points, run the tool? Do you just have different struggles at each instance? Like, how would that, what is a rerunning of the
Oh,
tool
yeah.
show?
So design-based research, you have to have at least 3-4 iterations, right? So in most of my studies, I do 5. And there are interesting patterns that we see. The types of struggles, and we can categorize them, the types of struggles they're having become less problematic. As in, if they're struggling with, at first, in that project, they were struggling with teamwork and their freeloader peers and all of that. And we did design those iterations, and that kind of struggle went away by the 3rd iteration. And then they were struggling with things that are less problematic, like finding time to go interact with the stakeholders outside the class. I mean, that's problematic, but it's not as problematic in terms of learning.
Right.
But there's other patterns as well that we noticed in the early iterations. Then there tends to be just a few clusters, and then toward the end, almost always the same pattern. There's more clusters, which means, I think it means that there's a greater diversity of ways in which the learners are experiencing things. But also another interpretation which fascinates me is that the principles from the different learning theories are actually playing out now. And this is another principle from learning sciences, that you don't use just one theory to help you design your learning. You've got to use multiple theories because it's complex. So you better have different, perspectives that you're bringing in.
I appreciate the response. Thank you. And we definitely have time for some more questions if we have.
Or not the questions, or what's next?
What's
your
next?
ideas.
Yes, what's next?
Or what are you going to invent next?
So thank you, Jonan. This was really, really fascinating, and I really appreciated so many things in the framework that you've created. Um, some clarification questions, in order to really support our thinking about what's next and how to use this and how to apply. And um, when you talk about the design cycles in your course, the courses that or context where you are working with the professors, are the iterations happening in the same course, or are they happening across instantiation of the courses? So when you say with iterations, we see struggles shifting, for example, is it with the same students across the course, or with the same course at the same stage of the course at different implementations? Because I think that part of the issue here is also
Yeah.
time and is it the same students or
Yeah.
not? So can you describe?
So I think about maybe 90-something% of the time, it's actually one course, one semester. Because it'll be something like a design thinking project, which takes a whole semester to pull off.
Right.
But sometimes it's smaller things like I had one teacher who we came up with the idea of having preflection activities in addition to reflection activities. And in that case, it happened every week. So we could do all of the cycles in one semester.
Right. Cool.
Similar patterns came there, but I can say that across semesters, if you don't change anything about the design, the maps are going to look very different because it's different people. But there are always some aspects of, you always find something similar, like the types of struggle. So the students who struggle with teamwork and interaction with peers and stuff like that always have a certain set of struggles and often a connected set of things that work for them, no matter what the context is. Even actually, someday I want to do this kind of analysis from elementary school all the way through graduate school. There are some patterns. It might be just the human experience, but it might also be the nature of language, because we're coding language.
And maybe a methodology that you're using reflections as your mode.
Right.
So it's actually a cultural activity that you use in order to gather the data and its expression, and that manifests as well some patterns, right?
Yeah.
No, but all this is really fascinating. And one of the things that I wanted to ask or to engage in conversation about is it's basically like using the reflections to get a snapshot of the system in a particular moment of emergence. Its emergence. And I appreciated your using of multiple theories, and the clusters seems to be reflection of the meaning making of the reflectors in which you code. And then you have this cluster that are like using theoretical nodes from multiple perspectives. And what did you learn from this, looking at these clusters? And because part of what I appreciate, and I think that it can be highlighted even more in what you're describing, is that part of the design-based research approach is informing theory as you engage in the analysis. So it's not just, I'm looking at the data and then what I learn, the theoretical principles, but here is a new theoretical principle that is emerging here from the analysis of the data, and it's simultaneously improving the practice and contributing to theory development. So part of these clusters is a theoretical insight about how different theories actually are integrated in the experiences reflected in those particular data. But definitely the theories are merged into experience.
Yeah. And also, what I was most interested in is not just contributing to theory or making new theory. It was relationships between principles from different theories. That is cool. Like, for example, we did a study where we had the students do the reflections every week for many weeks, and then we made the maps for every week. But what we found was the relationships between the theory principles. It was basically that at the beginning of the semester, then transformative learning theory principles just really were not showing up at all. Situated learning theory principles, not showing at all. Activity theory principles, not at all. It was basically cognitive constructivist, a little bit of self-determination. But it was constructionist theory principles that pulled things along and almost bridged it. So more of the transformative learning theories were, or those other theory principles, it's like the different principles from that theory were not in one cluster. They were in many different clusters, but they were connected more to different theories in a consistent way. And I was like, this is why you have to use multiple theories. And that is a theoretical contribution in itself, right?
Yeah. So Jonan, what you make me think about when you think about like next steps is an idea that I've been working on with my co-author, and that is this idea of a complexity paradigm, where if you are really going to engage in the mess, to limit yourself to one particular set of theoretical principles can often lead you unintentionally, unconsciously, to be biased in how you're perceiving this complex system. So I think this work that you're doing is really excellent in that it provides a way for people to have a justification for reframing the theoretical discussion and allowing people to innovate based on that reframing, because innovation can only occur if you allow boxes to be deconstructed and reimagined. And so to me, I think these next steps of bridging theory and practice is this idea of a complexity of paradigm that allows you to pick and choose, so to speak, in a justifiable way, not like randomly without justification. Yeah. So anyways, when you talk about next steps, that's kind of where my brain is going.
And I think the complexity paradigm really helps with other little aspects of it as well. For example, learning theories, in my oversimplification, are basically different definitions of learning. So situated learning theory might be like, of course, it's more complex than this, but it's becoming within a community of practice. If it's becoming, you need another theory that's a theory of identity, because identity, that's the becoming, right? So you need a theory of identity. And if you have a complexity perspective, then you're going to need to go find an identity theory that is compatible with complexity perspectives. Fortunately, there's one here. Sorry, a very good one.
Do want to be mindful of time. We're about 10 minutes left. So if there's any, maybe one more question, if there is. Perfect. Well, I'll share my slides real quick.
Well, I have actually one more question, just for you're working with professors, so bridging the theory and practice. How do the professors of the different domains, how do they respond to, and what scaffolds have you been using to interact with them in a way that they say, oh, I understand, oh, this is an insight, and not surprisingly, I'm thinking about, using the DSMRI, and some of what you described was so DSMRI congruent, like, the examples that you provided. Oh, in this course, they thought about their role as a student more as an employee, and the teachers more as a boss, this is like DSMRI lends itself so well to, and then in another course, they thought about, no, my role is to try to emulate the professor. But so how do you find, what scaffolds do you find constructive to talk to the professors about what's going on using the LENA?
So every time I start a new project with professor or other teacher, like even elementary school or something like that, then I start with a very narrow focus on a specific learning activity, not the course, just a specific thing, because that allows me to start scaffolding them in learning theories, which they don't have any experience in whatsoever, which allows me to, we don't have to learn all of the theories. For example, the project about reflection and preflection, we just had to start with transformative learning theory because reflection is a huge part of that. And we used a bit of cognitive constructivist because schema building, and that's reflection is important for that. And we just started with those two in terms of the design of the activity. But then analysis starts bringing out these other ones and they're like, what is that? And I'm like, okay, time to learn. And I don't have to like try to teach them everything. They're just intrigued. They're like, this is my class, my students, and there's a node of theory that is so cool. I want that. What is that? And then it's really easy to scaffold from there.
Perfect. Well, thank you
Are
for the
we
discussion.
allowed to ask questions? I was stymied because he wants to go beyond, and I have questions about the presentation itself. May I, Elvin?
Sure, maybe 2 minutes. Just have some announcements at the end, and then we're going to close it up.
Okay.
But please ask your question.
All right. First of all, thank you for your tinkering, Jonan. It was an interesting, very interesting presentation. Earlier, you dismissed, and I understand why, multiple choice questions as being too reductionist. So I've been writing about reductionism and how complexity theory is not reductionist and da-da-da-da. And meaning that it's not the search for the lowest possible level that has a causal principle, simple causal principle. And that's what I mean by it. It's called ontological reductionism. But there's been an article fairly recently critical of that, saying, critical of me actually, saying that it has to be, complexity theory has to be reductionist, because how can you possibly study everything? It's a complex system. It's all interconnected. Where are the boundaries? I call it the boundary problem. And, some Reagan talks about the casing problem. So I guess when you said, multiple choice questions are reductionist, can you tell me what you mean by that? And can you help me with replying to this critique?
Oh, just what I mean by it is that in order to do this method, then you need to get data on the student's actual experience, which requires reflection, and multiple choice reduces everything to numerical values that, well, number one, you can't really make good network maps out of those, but also it just, how could you possibly get theoretical principles from quantitative data in the same way that you can get them from qualitative data? Like the students are talking about their experience. You know the theory. You could never ask the students, okay, which theory principle does this align with? No, they're never going to get that, right?
So it has to do with the nature of the data and what it reveals. Yeah. Okay.
Yeah. But of course, Avi could answer this question a lot better than me. But I would say that the best argument for me is that all of the ideas that saying it's not possible without reductionism, there are so many scholars who have just told exactly the kinds of like refutations of that are basically too strong of an argument to avoid. So whoever's making those arguments, I'm it's okay. People need to have different perspectives, but they might not have engaged with the literature enough. I'm not sure.
Yeah, that's been part of my response so far. Thank you.
Before we finish, Avi, I want to know your quick thought on that.
I mean, the quick thought is like every research is simplifying the phenomena itself. The question is, do you, right, that it's almost by definition. The question is, does the theoretical approach and the method capture the essence of the phenomenon rather than completely
Simplifying it.
reducing it inappropriately to dimensions that are actually not really explaining or capturing the nature of the phenomenon.
Yeah.
See, I knew you would say it better than me. Thank you.
Perfect. We have about 3 minutes left. So I do want to take some time and just, thank Dr. Donaldson for his presentation. So if you just want to join me in a round of applause, please. Thank you so much for sharing. I do want to highlight, so our next webinar. So we have Dr. Diane Larson Freeman here. So next month, it'll be the complex dynamic systems theory and second language development. We'll drop the QR code either on the screen or we have it in the chat. And the last thing I want to do is we'll drop the link to the newsletter. And if you have any troubles accessing it, please contact Ali or myself. And the rest of the information here, will be in that newsletter. So I want to stop the recording at this time and just thank everyone for your afternoon. And we'll see you next month for the next webinar.